Hello everyone and welcome back to my channel. In today's video, we are going to learn about recursive CTE by going through a real world example, building a file directory tree, just like how your computer organizes folders and files. This is one of the most powerful use of recursion in SQL, and by the end of this video, you will be able to visualize and write recursive query with confidence. So let's get started. First, a quick recap. A recursive CTE or a common table expression is a SQL feature that allows you to query hierarchical or tree structured data. It works by calling itself just like a recursive function in programming. A recursive CTE has two parts. First is the anchor member. This gives the base case or the starting point. Then comes the recursive member. This repeatedly adds rows by referencing the previous result. The recursion continues until no more rows are returned. Now let's apply this concept to a real example. Imagine we have a dataset representing a file system, folders and subfolders, and it looks something like this. Here, every item has an ID, a name, and a parent ID. So, root is the top level folder, documents and music are inside root, and resume.pdf is inside documents. And same goes with other. Our goal is to rebuild the full directory structure using the SQL step by step. So, let's complete our recursive query and understand the query. So, this is the complete recursive query with anchor member and recursive member being written. So let's run our code and understand this query. We have an anchor member base case. This is the starting point of the recursion, like the root of a tree. It selects the topmost folder, the one that has no parent, that is, whose parent ID is null. Then comes the recursive member after union all statement, which keeps joining child rows to their parents, building the path as it goes deeper. We have also maintained a depth column to track the folder level and the full path column to build something like root slash documents slash ideas slash notes.txt and etc. Now let's understand step by step how this recursion works. In this Excel, you can see on left hand side we have a source table, and on top we have the source query being written. In iteration 0, starting with the root, this is the starting point of the recursion, like the root of the tree. It selects the topmost folder, the one that has no parent, whose parent ID is null. In our data, ID equal to 1 and name equal to root has parent ID is null. It sets depth equal to 0 because this is the top level. So the full path will be root as it initializes the path. In iteration 1, we find the children of root. Now we recursively run the query, select f.id, f.name, f.parentid, dt.depth plus 1 as depth, dt.fullPath, and concat it with slash and f by f.name. From file system f, we will be joining with the directory tree dt on parent id and id. Until this point, the directory tree is only having the root, but now documents with id2 and music with id3 will get added. In iteration 2, we find the children of document and music. Until now, directory tree contains root slash document, and root slash music. We join again on parent ID 2 and 3 with file system and get ID 4, 5, 6, 7, 8. In iteration 3, we will find the child of ideas as other IDs don't have any child. Now we'll look for children of ideas with ID equal to 8, and we get ID 9 of path notes.txt. With iteration 4, since node.txt with ID 9 does not have any children. This means there are no more rows where parent ID matches any ID in the directory tree. So the recursion ends here and we get the final output being present here. To summarize, recursive CTE are the powerful tree-like data. They begin with the anchor query, that is the base level. They keep adding children through recursion and the loop stops when no more children exist. If this video helped you to understand recursion in SQL, make sure to like this video, share it with your peers, comment below if you want more example and subscribe for more deep dive into SQL tutorials. Thank you for watching and I will see you in the next one. Until then, bye.